order in which it's written in the equation does not matter at all. Now look here. Here we have ammonia, right? Can everybody see that? Even from the back, is that big enough to see back there? Okay. Here we have NH3 plus water. What do we say happens here? Ammonia gains a proton. So this is a base. Oh my goodness. And this is my acid, right? The water's going to give up a proton to the ammonia. So if this is a base, then this is the conjugate acid. If this is an acid, then this is the conjugate base.
So how did you determine on the left side what was acid and what was base?
Really what you have to do is you have to look at both sides to determine that. This guy differs from this one by 1 hydrogen ion. Well, how did it get from here to here? It accepted a proton, didn't it? Proton acceptors are bases. This guy differs from this one by 1 proton. Proton donors are acids. In this case, it donated, right? Because the difference between water and hydroxide is 1 proton, right? 1 H plus, hydrogen ion. So it gave up a hydrogen ion. It's a proton donor, hydrogen ion donor. It's an acid. So you kind of got to look at the whole thing to decide who's the acid and base over here. And then you come back and say, okay, this was linked to that. They're related. If it's an acid over here, then it's a base on this side. If this one's a base on this side, it's going to be an acid on this side. Okay? Like you said, like Angela said, base on one side, acid on the other, acid on one side, base on the other. It's not acid, acid, base, base. That doesn't work. Okay? So, it says every one of these is a base, is an acid, I'm sorry. Every one of these is an acid. What would be the base that you get from this acid? I'll do the first one so you can see it, and then I want you to do all of these, okay? If this is an acid, what is it going to do? What do acids do? They give up a hydrogen ion. So if this gives up a hydrogen ion, what do I have left? Not just bromine, but bromide. Because there's a hydrogen ion someplace, right? That's positive. If I take positive away from here, that's going to be left with a negative charge. Okay? So you guys try to do these two. And then down here, think about it. These are bases, so what do? They gain hydrogen ions. Okay?
The answer is just
Bromide. Yep. So basically, I want you to tell me, what do you have left? What's at the end? We're all good? Should we do them? Okay. This is an acid, right? It's going to give up a hydrogen ion. So what do I have left? I have HS, and it's going to be negative. Why is it negative? Because it lost a positive charge, and these charges added together have to give me where I started at, right? Here I started with no charge. Negative and positive added together is nothing, right? Ask me. Come on.
I don't know what to ask. There's a hole in it, but I don't know.
Do you see the difference between this and this? That there's one hydrogen that went away.
Yeah.
Because this is an acid, it's going to give that to somebody else.
Okay.
And because this is positively charged, the thing it gave away was positive, this has to be negative. Because we started with 0. And I gave a positive, so that made me negative. Because these two added together have to get back to 0. Plus 1 and minus 1. This charge is 0, right? On this, H2S has no charge, does it? That's 0. These two charges added together have to give me back to 0. That's why it has to be negative. No? Let's try this one. Let's let Jennifer work us through this. Come on,
It's gonna be a long day.
you can do it. I know you can do it because I've been watching your grades. I know you're fine.
I don't know what I don't understand.
All right, well, watch and tell me. What do I have left if I get rid of a hydrogen ion right here?
1 hydrogen.
Uh-huh. A carbon and 3 oxygens, right?
Uh-huh.
Now, what's the charge on that going to be? If I got rid of something that was positive, because I got rid of a hydrogen ion, then this has to be what?
Negative.
It has to be negative. That's it. That's all it is.
So if it's a conjugate base, you just assume it's probably negative.
Most of the time it will be.
But I don't get how, I mean, is the hydrogen on the one that you just said,
Uh-huh.
is the hydrogen on the right side
Right here.
also a negative charge?
The whole thing is negative. This is called the bicarbonate ion, right? It's all together. It's polyatomic ion. The whole thing has a negative charge. Just like this one right here, the whole thing is negatively charged, polyatomic ion. Okay? You're not trying to say that that's on one of the oxygens or anything like that. Okay? Now these are opposite, these are bases, right? What do bases do? They accept hydrogen ions, don't they? So if I have -1 and so if I take nitrite, oops, I wrote nitrite, and I add H plus to it, what do I get? HNO2. Okay? Same thing with ammonia. If I take ammonia and I add H plus to it, what do I have?
NH4.
NH4 positive.
So the first one's not positive
Because it started negative, right?
Okay.
So it didn't go, it went from negative, it went up 1, right? This started at 0, it goes to +1. These are going down, right? Because they're losing positive, so they're getting more negative.
Okay.
All right, now here's OH minus, hydroxide ions, plus hydrogen ions. What do I have now? Now, I don't know if I told anybody in here it's in my lab. Sometimes I'll write this as don't do that mastering because it'll count it wrong. But I write as HOH sometimes. Why do you think I write as HOH? What do you think? What can I see if I write as HOH? I can see hydrogen ions and OH ions. These came from the base, this came from the acid, right? So when I do acid bases, I often will write as HOH, just so I can see that a little bit clearer. And at the end, I'll go back and rewrite it as H2O. Okay? If you're trying to balance acid-base reactions, which we'll get to next week, you can see it a little bit easier sometimes like this. Okay? Fair enough? All right. All right, there's 5 pairs up here. 3 of these pairs are conjugate acid-base pairs. Look at them and tell me which 3. We'll do them one at a time in a minute. You can tell me yes or no when we get to them. How do you know it's a conjugate acid-base pair?
One is different.
They only differ by 1 hydrogen. Hydrogen ion, right? Is the first one a conjugate acid-base pair?
Yes.
Yes, it is, right? The difference is just 1 H plus. What about the second one?
No.
Why not?
It differs by 2.
It differs by 2 hydrogens, doesn't it? What about the third one?
Yes.
Yes, no, maybe?
Oh, I didn't see the fourth.
The first one is HCl. The second one is ClO4.
I was just looking at this.
Where do all those oxygens come from? Have we said anything about oxygens and acid bases?
It didn't even-
Not even close, is it? All right, what about the fourth one?
Yes.
Why? All right, HS minus is acting as what here? Is HS minus an acid or a base? HS minus and H2S. HS minus, is it acting as an acid or a base? A base, it's accepting a proton and becoming H2S, isn't it? Okay, and then the last one.
Yes.
Yes, it is. That's ammonia, right? NH3. It accepts a proton and becomes NH4 plus. That is ammonium, right? This ammonium, NH4 plus, that's a polyatomic ion that we learned about before. All right, let's go back up to our other conjugate acid-base pairs. So this one was, these two are not, right? Is this acting as an acid or a base? This is an acid, right? It loses a hydrogen and becomes the nitrite ion, okay? All right. Identify the conjugate acid-base pairs in this reaction. Let's look at it. On the reactant side, who is the acid on the reactant side? HNO3? Why do you say it's an acid? It loses a hydrogen, and who does it become when it loses its hydrogen? The nitrite ion. So that makes nitrate conjugate base. All right, if this is an acid, that means that this must be a base. And that means that this is its conjugate acid. What do you say, at least one of us does? Strengths of acids and bases, right? Here's our friend hydrofluoric acid in a plastic bottle. And remember when we wrote hydrofluoric acid, we wrote it with 2 arrows, right? Ooh, wow. We learned about 2-headed arrows in the last chapter, didn't we? Weak electrolyte, right? That means it doesn't go 100% to this side. Some of it's still over here. Okay, remember that in the last chapter? Strong electrolyte, weak electrolyte. Weak acids only partially dissociate. Strong acids, on the other hand, 100% go to the right. Weak acids only partially go to the right. Now, how partial is it? It could be 10%, it could be 20%, 50%, it could be 90%. Strong acids go 100% to the right. That's why there is a 1-headed arrow here. Weak acids only go partially to the right. That's why there's 2 arrows there. Back and forth. Okay?